Well, welcome to Lecture 2. We'll start today by learning a little bit about the addition and subtraction of binary numbers. So let's go to problem 117 for an example. We'll start with problem 117A. In this problem, we're asked to add and subtract these two binary numbers, 1111 and 1001. Notice that they don't have a subscript of 2, so the way that we know that these are binary numbers is that it states it in the statement of the problem. So the addition of these two binary numbers is straightforward. It goes like this. We'll write the first number 1111 and then write the second number under it 1001, and now we want to add those, keeping in mind that they are binary numbers. So we just as we would with decimal numbers, we start with the rightmost digits, and over here at the rightmost side we have 1 and a 1. And of course 1 plus 1 is equal to 2, but we can't have a 2 in binary arithmetic, so we'll write down a 0 and carry 1. Now when we go, then we move left and look in the next column, and we have 1 and 0, and once again that's 2, so we write down a 0 and carry 1 there as well. And here when we move left one more column, we have 1 and 0 is again 2, so we write down a 0 and carry 1. And now this time when we look at this column farthest to the left, we have 1 and 1, which is 3, so we write down a 1, and then we carry over a 1 to this non-existent column, and 1 and then the 2 blanks just gives us 1, and so this is our result. We conclude that 1111 plus 1001, both of those are binary numbers, is equal to 11000. Now let's just check this to make sure that it is correct. So we'll look at each of these numbers in binary, and in decimal, and make sure that we do have the right thing here. If we, as usual, if we label the positions here 0, 1, 2, and 3, then we see that that top number is 1 times 2 cubed plus 1 times 2 squared plus 1 times 2 to the first power plus 1 times 2 to the 0th power. And that is 8 plus 4 plus 2 plus 1, which will give us 15. If we do the same kind of thing for the second number, we have 1 times 2 cubed plus 0 times 2 squared plus 0 times 2 to the first power plus 1 times 2 to the 0 power. And so that's equal to 8 plus 0 plus 0 plus 1, which will be 9. And our sum, when we add these as decimal numbers, is 24. Now let's look over here at the binary number that we obtained and see if it is indeed equal to 24. Well, we will again number the positions, so we have 0, 1, 2, 3, and 4. So this number is 1 times 2 to the 4th plus 1 times 2 cubed, and then everything else is 0. So I'll just go ahead and write plus 0. And of course 2 to the 4th is 16, so this is 16 plus 8, which is indeed 24. So this works out, and we have the correct answer. Now, when they ask us to subtract these numbers, it's not clear at the beginning whether they mean for us to subtract the second number from the first or the first from the second, but I will assume that the book intends for us to subtract the second number from the first number. So we will have 1, 1, 1, 1 minus 1, 0, 0, 1. And let's see how this will go. Well, 1 minus 1, starting at the right, 1 minus 1 is 0. And then 1 minus 0 is 1, 1 minus 0 is 1, and the 1 minus 1 is 0, which you can write down if you wish, but you don't have to write it down. So we conclude that 1, 1, 1, 1 minus 1, 0, 0, 1 is 1, 1, 0. And once again, we can check our work. We learned above that the first number is 15, and the second number is equal to, you recall that's equal to 9. And so when we convert these to decimal first and subtract, we would get 6. And if we check 0, 1, 2, this number is equal to 1 times 2 squared plus 1 times 2 to the first power plus 0, which is 4 plus 2, and indeed it is 6. So we get the correct answer for both the addition and the subtraction. And I think that that's fairly straightforward for that problem. So now let's look at problem 1.17b. This one is a little bit longer, and I think we'll demonstrate also some other ideas. So let's see what will happen here. We're asked to add 1, 1, 0, 1, 0, 0, 1. No, that's the first number, and the second number is 1, 1. Sorry, I better start from the right because this second number is shorter. Okay, so the first number again is 1, 1, 0, 1, 0, 0, 1, and the second number, reading from right to left, is 0, 1, 1, 0, 1, 1. So all of a sudden, already we see one difference from the previous problem, and that is that these two numbers do not have the same number of digits. The first one has 7 digits, and the second one has 6. Once again, now we will add these two numbers, and then we will subtract the second number from the first number. I encourage you to stop the video now and try this on your own first, and then come back and we'll all do it together. Okay, so let's now check your work and see if you got the correct answer. Adding, I think, is still fairly straightforward. 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and 1 and 1 is 2, so that becomes 0, and I carry a 1. Again, 1 and 1 is 0, and carry 1, and 1 plus blank is 1. So we conclude that 1101,001 plus 110110 is 100,11111. And again, I don't think it's bad practice at all just for us to check our work. So let's see what happens. If we number our positions, then this first number is 1 times 2 to the 6th power, which is 64, plus 1 times 2 to the 5th power, or 32. And then we don't have any 16s, but we do have 1 times 2 cubed, which is 8. We don't have any 4s, we don't have any 2s, but we do have a 1, so plus 1. So this ends up being 96 and 8, which is 104, plus 1 is 105. 105. Now let's look at the next number. It has a 32 in it, and it has a 16 in it. It doesn't have any 8s here because we see in this column with 3 that there's nothing. It does have a 4 and a 2, but it doesn't have, you see here in the 0 column, this has a 0, so there's no 1 there. So I think that this takes care of the second number, and we have 32 plus 16, which is 48, and 6 is 54. So the sum is 159. And now let's look at the answer that we obtained over here and see if that is indeed what we got there as well. Okay. Well, if we look at the positions in this number, we see that the first one is 1 times 2 to the 7th. And 2 to the 7th is 128. So this first one right here, the one over on the extreme left side, that's 128. Then we don't have any in the 6 column. We don't have any in the 5 column. But in the 4 column, we do have a 1. And remember, as we said before, 2 to the 4th is 16. So we have 16. And then in the 3 column, we have a 1, so 8. And in the 2 column, we have a 1, so that's 4. In the 1 column, we also have a 1 here, so that's 2. And finally, in the 0 column, we have a 1, so that gives us 1. And let's check and see what this is equal to. Well, 128 plus 16 is 144. 144 and 8 is 152. 152 and 4 is 156. 156 and 2 is 158. And 158 plus 1 is indeed 159. So we have arrived at the correct answer. And I hope that you did get this when you worked on this on your own, because this is, as I say, I think that this is fairly straightforward. But the subtraction part of this is maybe a little bit tricky, so let's look at that and see how it goes. So we now will have 1, 1, 0, 1, 0, 0, 1, minus 1, 1, 0, 1, 1, 0. And we'll see how this goes. Well, going from right to left, as we usually do when doing these kinds of calculations, the first column is easy. 1 minus 0 is 1. But now we immediately are going to have a difficulty in the next column because we have 0 minus 1. So we need to borrow just as we do in decimal arithmetic. And so what we're going to do here is, of course, we can't borrow from the number that is immediately to the left of the 0 because that's just another 0. So we have to borrow all the way from this one. So we're going to cross out this 1 and make it a 0, and then that will make this 0 equal to 1, and effectively this 0 becomes a 2. Now, of course, you can't really have 2 in binary, but don't worry about that because we're going to take care of that in just a moment. So we now can have 2 minus 1 is 1, and then when we move to the next column, 1 minus 1 is 0, and then now remember in this column the 1 that was there has become a 0, so we have 0 minus 0 is 0. Now again, we have the same kind of situation here. We want 0 minus 1. We can't do that, so we can replace this 1 by a 0, and then this will become a 2, and 2 minus 1 is 1. And now we have 0 minus 1, so again we're going to have to pull this trick, replace that by a 0, and make this a 2, and we have 2 minus 1 is 1. So just since I've been writing through numbers, I'll rewrite the whole problem. So what we are concluding now, if we haven't made any mistakes, is that 1101,001 minus 110,110 is equal to 110011. Now, I personally believe that the easiest way to check our work here is to simply add the two numbers and see if we get add the result in the second number and see if we get the first number. So let's check that and see. So we have 110,110 plus 110011. Let's see if when we add these we get the top number. So 0 and 1 is 1, 1 and 1 is 0, carry 1, 1 and 1 is 0, carry 1, 1 and 0, 0 is 1, 1 and 1 is 0, carry 1, and 1 and 1 and 1 is 1, carry 1, and 1 and blank is 1. So when we add those two numbers, we get 110,1001, and if you compare this to what we started with, we see that it is exactly what we did start with, and so that gives us confidence that this number here is indeed the correct answer. Now, of course, if you wanted to, another way to check it would be to convert all of these numbers to decimal. We know that the top number is 105, and the second number is 54. We know that from our previous work, and therefore this number down here should be 51. And if we check that, let's see, let's number the positions again: 0, 1, 2, 3, 4, 5, and you can see that this number down here is indeed 32 plus 16. It doesn't have any 8s or 4s, but it does have 2 and 1, and so that is indeed, if you add those numbers up there, you do indeed get 51. So this is another way of checking it and concluding that we have done our subtraction correctly. So that's how we handle addition and subtraction in of two binary numbers. And well, that's the end of that topic. Now we want to go to something a little more complicated, and this is referred to in your book as 2's complement arithmetic. And the example problem that we're going to look at is problem 134. Now, we're not going to do everything that problem 134 says. It talks about both 1's complement and 2's complement, and we're not going to do every single bit of that, but we do want to concentrate on 2's complement. So let's try to learn a little bit about this, and as usual, we will try to learn by doing an example. So in this problem, they want us to, this is part A, they want us to do the following calculation: 0, 1, 0, 0, 1 minus 1, 1, 0, 1, 0. But they tell us in the instructions, they say, assume that negative numbers are represented in 2's complement. Now, what does that mean? All the numbers that we've been dealing with so far have been positive numbers, and so what do they mean when they talk about negative numbers? Well, the first thing we have to understand is that when we start talking about 2's complement, if we say that a number is represented as 2's complement, or some people would say a signed binary number, that means that the first bit in the number tells you about the sign of the number. So, for instance, when we look at this top number here, the fact that the first digit is a 0 tells us that this is a positive number. So the top number there is positive 9. Now, the second number, though, is trickier. The second number, since it begins with a 1 here, that tells us that this is a negative number, but we have to ask ourselves, well, what negative number is it? So before we can do this problem at all, we ask ourselves, again, the book says that we are to assume that negative numbers are represented in 2's complement. So what does that mean? And how do we interpret this this negative number? What, again, I want to emphasize, we don't even know right now what negative number it is. So let me show you how you answered this question. Okay. We have 1, 1, 0, 1, 0. And I'm going to go ahead and write down is a negative number. And what negative number is it? That's our question. Now, the way that you find out the answer to this is the following. The leading one and I'm talking about this number right here, tells us the number is negative. Now consider the rest of the number. Now the rest of the number is 1010. That's your first step. 2, take the complement of every digit left of the first one as you move from right to left. Okay, so let's think about this. We're going to move from right to left. on this number here, 1 0 1 0. So we're going to move from the right to the left, so we're moving in this direction. Now the first number we encounter as we go over to the extreme rightmost edge is this 0. And since that's a 0, we don't do anything at all. So we can write down, we'll still have 0. Now the next number as we continue to move from right to left is 1. So now we're encountering our first 1. Now we don't complement anything yet. We complement everything to the left of that first 1. So we go ahead and put down the first 1, but now everything else will be complemented. And what do we mean by complemented? It just means it will flip. So if it's a 0, it'll change to a 1. If it's a 1, it'll change to a 0. So now that we've encountered our first 1, as we continue to move from right to left, this 0 will become a 1, and the 1 here at the beginning of the number, or perhaps should say at the leftmost side of the number, this 1 will become a 0. Now, we know that this binary number right here, if we numbered the positions in it, 0, 1, 2, 3, then this is 1 times 2 squared, which is 4, plus 1 times 2 to the first, which is 2, and 4 plus 2 is 6. And therefore, we conclude that the number we started with up here, 1, I'm talking about this number right here, 1, 1, 0, 1, 0, if that is in 2's complement, and which is what the problem is telling us to assume, that number represents negative 6. We know it's negative because of the leading 1, and then we find out the magnitude of it by using the procedure that I just showed you. So, let's just rewrite our entire problem and see if we can complete it and see if it works out correctly. So we have, again, the problem that we want to do here is 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, minus 1, 1, 0, 1, 0. This is what we want to do. And we have found out that the first number is positive 9. And then we're going to subtract from that a negative 6. This is what we're doing. And of course, we know that our answer should be 15. But let's see if this is correct. Well, first of all, you have to ask the question, how do we actually do this subtraction? Because since the second number is in 2's complement representation, that would lead you to believe that probably something is a little different here, and indeed it is. What we learn is that when you take the 2's complement of a number that is in the 2's complement representation, you will get the negative of that number. Now let me show you what I mean by that. We have this number, the second number is 1, 1, 0, 1, 0. If we take the 2's complement of that number, we'll call this number n. The book uses the following notation: 2's complement of n is denoted as n star. And again, the way that you get that is moving from right to left and complementing everything to the left of that first one encountered. So we would get 0, 0, 1, 1, 0. Okay? And so now the final step in our reasoning is the following. If the 2's complement of a number, remember this number right here is the 2's complement of this number that we are subtracting, which means it's the negative of that number. And so our reasoning is this: subtracting a number is the same as adding its negative. So we are saying the following: 0, 1, 0, 0, 1 minus 1, 1, 0, 1, 0. That's the same thing as 0, 1, 0, 0, 1 plus the 2's complement of that second number, which we have just found out is 0, 0, 1, 1, 0. And let's see what that would give us, and then we'll put this all together. And by the way, if this seems confusing to you, it's because it is tricky. And don't worry, we'll look at several examples before you'll be asked to do any of this. So if we add these two numbers up, we get 1, 1, 1, 1, and 0. And of course, if you evaluate this number, if we, as usual, we can label the positions 0, 1, 2, 3, and the first one is a sign bit, so we don't have to label it. So we have 1 times 2 cubed, which is 8, and 4 is 12, and 2 is 14, and 1 is indeed 15. And that was what we predicted that we would get. When we take a 9 minus a negative 6, we get 15. And indeed, by doing this trick, we do come up with the right answer. Now, again, I'm not at all surprised if this seems complicated to you, and I hope that you're not too concerned with that, because now we're going to look at it again, and I think after a few examples this will become clear. So let's look at another example. In this case, we will look at B. So we want 1, 1, 0, 1, 0 minus wait just one moment. Okay, so we have 1, 1, 0, 1, 0 minus 1, 1, 0, 0, 1. This is the problem that we want to do. Now, if you don't want to check your work, you can just do this problem directly. You don't even have to ask yourself what two numbers these really are. You can just do the problem directly. So let me do that for you first to show you how to directly do the problem, and then I'll show you how if we want to really know what's going on, what numbers we are subtracting here, we'll talk about that as well. So the only thing we need to know if we want to do this directly, the only thing we need to think about is this. As usual, remember, we're told that negative numbers are represented in 2's complement. And so as soon as we know that, then we begin thinking about the fact that, as I said in the previous problem, this is a subtraction problem, and subtracting a number is the same thing as adding its 2's complement. So we are going to, here we are subtracting a number, And so that number, as usual, now we're going to call the number we're subtracting n. And n is equal to 1, 1, 0, 0, 1. And instead of subtracting n, we are going to add n star, where n star is the 2's complement of n. So n star, remember the way that we do this is just move from right to left, complementing everything to the left of the first one. So we would get 0, 0, 1, 1, 1. And therefore, according to our reasoning, 1, 1, 0, 1, 0 minus 1, 1, 0, 0, 1 is the same thing as 1, 1, 0, 1, 0 plus 0, 0, 1, 1, 1. And the answer to this then is 0 plus 1 is 1. 1 plus 1 is 0, carry 1. 1 plus 0 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0. And the carry, when you're doing 2's complement, if you have a carry in this last position, you just ignore it. And so this would be our answer right here is 0, 0, 0, 0, 1. That we claim is the answer to this problem. And, you know, as I say, you might not understand why that's true because you don't know what two numbers these are right now. But this is the answer, and to be honest, that's all you really have to do to complete this problem. Of course, it's nice to really understand better what we're doing, and so now we'll learn how to do that. But that is the answer, is 0, 0, 0, 0, 1. Now again, we ask, well, what is this? Well, notice that in this case, both of the numbers, both the top number and the number that we are subtracting, are negative numbers. And how do we know that? Because both of them here begin with ones. So both of these are negative numbers, and according to what the book has told us then, since these are negative numbers, they must be represented as 2's complement. Now, we would like, if we're going to understand this problem in a greater depth, we would like to understand what negative numbers they are. So how do we do that? Well, the second number, we already can figure this one out because we've already done the work in calculating its 2's complement. If we look at the 2's complement here, remember this is 11001 is the second number. That's what we're calling n. And we found out that the 2's complement of n, which is denoted as n star, is 00111. Now we recognize this number as simply being in decimal. This is the number 4 plus 2 plus 1. This is the number 7. And therefore, remember now the 2's complement is always the negative, so that means that this number right here must be negative 7. Okay? So now we figured out what that second number is. Now we'd like to figure out the first number. Now I would encourage you to try to figure this out on your own first, and then we'll do it together. Okay, so I hope that you were able to make some headway on that, but now we'll do it all together. Now we're trying to figure out what this number is. Now again, that leading one tells us that it is a negative number. We'd like to know what negative number it is. So we'll now treat, if you don't want to use n, again we can say m. M is equal to 1, 1, 0, 1, 0. And therefore the 2's complement of that, again, move from right to left, and complement everything to the left of the first one that you encounter. So you get 0, 0, 1, 1, 0. That's the 2's complement of m. Of course, we recognize that this number is 6, and therefore m itself must be negative 6. So now that we have identified m and we have identified n, we see that this problem that we're doing right here is equivalent to saying, what is negative 6 minus negative 7? And of course, we all know that negative 6 minus negative 7 is the same thing as negative 6 plus positive 7, which is 1. And you compare that to the answer that we obtained. And of course, that is what we obtained. So, I know that the 2's complement form is sort of complicated, maybe a little mysterious, but the whole point of it is that if you have the 2's complement, if you have this idea, then you never really have to subtract. Anytime you want to do a subtraction, instead you will just do the addition of the 2's complement of the number that you're trying to subtract. So let's pause for just one moment, and then we'll resume with still another example. I think that this is probably a good time to stop lecture 2, and so we need to go ahead and have our 2 test problems for this lecture. So for problem 2.1, let's have the following. Let's make the following. Let's say that we have the number 1, 0, 1, 1, 0. And this is in 2's complement representation. Okay? And of course that, I hope, doesn't surprise you. You see the leading one that tells you it's a negative number, and so we're gonna assume that this is in 2's complement representation. And so the question is, what is this negative number in decimal form? And okay, our choices are going to be A, negative 10, B is negative 8, C is negative 6, and D will be negative 9. So this will be the problem 2.1, is you need to pick which one of those decimal numbers is equal to that 10110 if we assume that it's in 2's complement representation. For problem 2.2, suppose that we want to calculate 0, 0, 0, 1, 1 minus 1, 0, 110. And we're assuming that this second number is in 2's complement representation. And I'm simply asking you to calculate this answer. You don't, if you want to check it, you're welcome to do so, but you don't have to check it. You simply want to calculate the answer. Is the answer 0, 1, 0, 1, 0? Or 1, 0, 1, 1, 0? Or 0, 1, 1, 0, 1? Or 1, 0, 1, 0, 1. Pick which one of these is the correct answer to this problem. So those are problems 2.1 and 2.2. And that concludes Lecture 2.